Hello, bro, gamins. Hold on.
Subway did what? Any foot long for $6.99 when you order in the app? Yep. Better hurry before it's gone.
Yep. Fueled by ProPlans. See our full story at ProPlansport.com.
Alright. We're back, Jogamin. Hold on. Okay, welcome back to Jogamin. Today we will be doing some Sigma stuff, like this test. So let's just start off. How to do 1A. Lim x approaching 3, 9x squared over 3 plus x. Alright. Let's just plug in 3. Alright, watch this chat. And as you can see here, that this turns into 0 and this turns to 18. So we got 18 over 0. Okay? And the question asks, why does it not exist? Show why. So to show that this limit does not exist, you must write that lim x approaching of some number, let's just say that, equal dne y, because lim x, or just the limit of anything to 0 is infinity slash negative infinity. So it must be dne because both limits are not equal. So just write something like that. But you might have to explain a little bit because what the frick. Okay, 1b. So 1b is cos b tan b over b. No, I'm not gonna write the limit yet. I'm too lazy, but so we're just gonna make tangent into its real form of cosine b. No. Sin b over cosine b, and these cancel out, so that will equal to sin b over b, and the limit of b approaching 0. Now, you need to know this limit as equal to 1. There's no teaching you that one. You just gotta know. Those who know versus those who don't know. I mean, if you really want to know, I'm gonna show you how hospital. If you use el hospital, you get the root of b, so you go d over db, and then d over db, and that'll be cosine b over d, that's just 1, and put in 0, it's equal to 1. That is why sin b over b equals 1. Also because 0 over 0, you can't use el hospital unless there's 0 over 0. put in 0 for this, for B, sin B, and B, it'll be 0 over 0. So you must use El Hospital to get this. Alright. It's too loud. Okay. Next problem is 3. Okay. We're on break. Hey, someone told me to record on paper and no edits, so whoever told this to me, probably Simon, this is your fault. Alright, look at this function. And we're gonna find our values of A and B, make this function continuous. So, okay. Oopsies. -5. Now, let's look at the function. If it wasn't for this statement, -5 less than or equals x less than or equals to 1, if it wasn't for this, then we wouldn't be able to make this function continuous. Okay, so make sure that either this and this have a bar under it, or these two have a bar under it. Okay, so then you actually know it can connect and touch each other to be continuous. Next, now that we know it can be continuous, we must find values of A and B to become continuous. So we're gonna write some equations, system of equations. Since continuous means that the values between this one and this one have to be equal, we'll just set up the equation for that. And we'll plug in x for -5 because that's where they meet. So 9 is equal to -5a plus b. And then we can write b minus 3x equal to a plus b, because 1 times, yeah, a, there's a 1 on the x. Yeah. Oh yeah, my bad. Get rid of this x because it's 1. Okay. And instantly you can find a by just canceling out b from this side and that side. So a equals -3. Now plug in -3 into this. 9 equals -5, -3 plus b, and that's just 15 equals 9 plus b, and therefore b is equal to -6. So a equals -3, b equals -6. This is pretty easy. I'm not gonna lie. Alright, 4. 4. Alright, you know what? I'll just show you on here. Okay. So, the question here asks for each condition. Alright, so the condition 1 is x approaches 2, f of x equals 3. Look at the graph here. Which one where both sides that are continuous at 3 or 2 approaches 3? I drew it on the test. Look at this. That is 3, and there is no hole, so G1 works. G2, there is a hole at 2, and it doesn't even reach 3, limit-wise. This one, both sides are unequal, so therefore the limits, the actual limit on both sides, is not equal to this. And here, this does work, because the limit, even though there's this continuity here and there's an actual value here, the limit approaches 3 when it's at 2 on both sides. The next one is f is continuous at 2. Only g1, this one, is correct. Because as we can see, these have holes. And this one straight up aren't even equal. And this is the only one without a hole, so it's only g1. The next one is limit as x approaches 2 from the left side equals 3. This one already works. This one works because on the left side is equal to 3, and this one works because these two carry on from this, and then we add g3 because on the left side it equals to 3. There you go. Next, burn. Okay. Next question. So it says lim x approaching pi over 2 of sin x e to the x minus e to the pi over 2 over, under is x minus pi over 2. So all we have to do for this is find the original equation. It's right here. That's the original equation. We have to find the derivative and put in pi over 2. Okay? Let's start it with the skibbity dum dum. I'll just write here 5. The skibbity dum dum dum, yes, yes. The skibbity dum dum dum, yes, yes. Skibbity dum dum dum, yes, yes. So f prime x, it's a product rule. So we first get sin derivative cosine x, and then we put e dx plus e to x derivative is just e dx, and then times sine x, and we put in pi over 2 cos pi over 2 e to the x, or e to the pi over 2, plus e to the pi over 2 times sin pi over 2. Now, if you don't know what pi over 2 looks like, or where it's on the circle, it's, pretend this is a circle. And center, pi over 2 is exactly perpendicular right here, up 90 degrees up, pi over 2. And sine is top, the up, and the cosine is the side. So that means if it's exactly perpendicular to the radius, or right here, then that means cosine is 0. There is no horizontal, so that's 0. And this is exactly 1, because on the graph, this would be at 1. Pi over 2 would be at 1. The angle pi over 2 would be at 1. So sin would be 1. And the answer equals pi 8 to the pi over 2. Yes, yes. Break time. All right. Okay, next problem. Okay, next one is 3x squared times CX. Alright, so I think we saw that problem. 3x squared times CSCX. Skibbity. So product rule, just use product rule. So 2 times 3 is 6x. And then minus that x right there, and then CSCX plus, now CSC derivative is negative CSC cotangent. So that's actually a negative CSC x cotangent x times 3x squared. And basically that's it. The answer is CS. Now remember to write your x's on your thing, on your trig functions, because I forgot to write it here, little bro Simon. And bro like, want the flap? And because I didn't write it, I got a 3.9. I forgot the x, guys. I forgot it like in this video too, so. Alright, number 7, I'm doing that. Get the poopy out of here. Alright, another break. Read that problem. Alright. What it's saying is, you have a quadratic function, and it has a tangent line with a slope of 8 at the point 2, 4. So at 2, 4 of this function, it has a slope of 8. And this function has an intercept of 1, 0. So let's solve this. Skibbity dum dum dum. Zam! Hold on, guys. Also, hold on. Report to Chow that this guy is cheating mid-test. This guy was cheating mid-test. He's cheating mid-test. Alright. Alright, so let me show you the problem again, if you forgot. Alright. So let's write it out. F of x equals ax squared plus bx plus c. And let's get the derivative. We always get the derivative of these type of questions. So you should get something like that as your starter. So we already know the point of tangency and the slope. So we're given 2, 4 at the point of tangency with a slope of 8. So m is the slope of the line or tangent line. And then we have a x-intercept of the parabola at 1, 0. So here you go. So let's put in 2 for this function. F prime 2, which also equals 8, by the way. So 8 equals 2 times 2a plus b. And therefore 8 equals 4a plus b. Okay? Remember that. Skibbity, 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 skibbity. Okay. So then also put in 1 into the original. Do not put this one into here, into the derivative, because this is talking about this one, not this one, okay? So we have 0 equals a plus b plus c, because if you put in 1 for all these x's, they all cancel out. And it's equal to 0 because the y is 0. And it doesn't matter, not really matter what you do with this, as long as you don't set a equal to something. You can use b equals something or c equals something. I'm gonna use c. So I'll write c equals negative a minus b. Alright. Okay. Now I'm going to put this here back into the original function, because this is the y value for this function if you put in 2. So you get a times 2 squared plus 2b plus c equals 4, and that's 4a plus 2b plus c equals 4. And then look at this, hold on, look what we have right here. 4a plus b equals 8. Can this relate? Isn't 4a plus b equal to 4a plus 2b? Now we can do that and plug in 8, and we get 8 plus b plus c equals 4. Bang. Now we're gonna use back this thingy. Now, no matter if you used b or c, because if you use b equals minus a minus c, you get the same answer. Alright? You're still solving for a on this equation. So 8, which is what we got from here, remember, plus b minus a from here, replace it from c, equals 4. These b cancels, and then we subtract 8 and 4, so it'll be negative 8 equals negative 4, 8 equals 4. Butter skibbity dum dum, yes. And then from then on, you can just plug in a for any of these b's or whatever that has only b. So we'll plug in a for the derivative over here. So 4 times 4, because we replace a with 4, is 16, plus b equals 8. Now subtract b equals negative 8. Status with and then from then on, you can do c equals negative 4 plus 8, c equals 4. That is the answer. That is right. C doesn't. So a equals 4, c equals 4, b equals negative 8. Alright. So it would be like 4x squared minus 8x plus 4. That is the equation. Skibbity dub dub dub, yes. Alright. Let's go to these questions. So it says find the equation for the tangent line of x minus 1, x plus 1, 2 1/3. Okay. So we're given a function. This is 7a. Now, the equation for a tangent line equation is y equals, or y minus y1 equal m, or f of f prime a, and then times x minus a, a is 2 and y1 equals 1/3. So we have like a lot already. This is pretty simple. All you have to do is find the derivative of this, plug in 2, and use that as the slope, and put these numbers back in. So let's do that. So we're gonna use the quotient rule here. X minus 1 over x plus 1 derivative. You put a square on the bottom, and then you get the derivative of the top part, multiply it by this. Derivative of x minus 1 is just 1, because this turns into 0, this turns into 1, and then now all that's left is x plus 1. So you got x plus 1 minus, now same logic here, this turns into 0, we have to get the derivative of this, multiply by this. This turns 0, this turns into 1. 1 times x minus 1. So parentheses x minus 1. And distribute the negative. You get negative x plus 1. Negative x and x cancel out. 1 plus 1. Like what I was saying, so 1 plus 1 equals 2. So the derivative is x. 2 over x plus 1 squared. And all you have to do to find the slope, f prime a, is put 2. So 2 plus 1 is 3. 3 squared is 9, so it's 2 over 9. The equation would just be y minus 1/3 equals 2 over 9 x minus 2. That is your answer for that one. Skibbity dum dum. Skibbity. Okay. So next one, same equation, but we have to find a parallel line to it. It gotta be parallel. So let's see what we got. Okay, well, I'm back. Don't know where I really left off on. I was probably talking about how this line, if you simplified it, you would get 2y equals 6 plus x. Divide the 2, you get y equals x over 2 plus 3. Okay? And the slope of the equation would be 1/2. So what we have to do is get a derivative and find the slope that's equal to 1/2, because parallel lines means that their slopes are equal. Okay, so since it's the same equation, we just use the same derivative. F prime equals 2 over x plus 1 squared is equal to 1/2. And then let's just multiply x plus 1 on this side. No, I'll multiply 2 on this side. So that's 4. That's 4 over x plus 1 squared. And then multiply x plus 1 squared to this side. So now it's 4 equals x plus 1 squared. If you don't see it, multiply 2 times x plus 1 squared. And then on this side, 2 times x plus 1 squared. And this 2 cancels out. The x plus 1 right here cancels out. So yeah, 4 equals x plus 1 squared. Now let's expand. X plus 1, 2x plus 1 equals 4. And then solve. 0 equals x plus... And then we can do this. 2. It's just 3 negative 1. Okay. Yeah, that's 3 negative 1. So x minus 1, x plus 3 equals 0. And then x equals negative 3 and 1. And from here, use the tangent line slope formula thingy to get the equation using these two values. So let's start off with negative 3. If you put negative 3 in here, also by the way, we don't need to put negative 3 into the derivative because we already found it using the derivative. So it'd be, I mean, you can put it in to prove that it's 1/2, but we just solved that. So back to the original function, x minus 1 over x plus 1. Put -3 for x. That would be -4 over -2, which means that it would be -4 over 2 is just 2. So y minus 2 equals 1/2 x plus 3, because there's a -3. That's the equation. Now use 1. 1 plus 1 is 2. 1 minus 1 is 0. So there is no y1. So y just equals to 1/2 x minus 1. And those are the two equations right there. Skibbity, skibbity, skibbity. Alright, last problem is this right here. It says, determine the points, if any, at which the graph of the function has a horizontal tangent line of this function from 0 to 2 pi. Now, what it means by horizontal tangent line, it means that, let's say we got a graph, and I mean, it's cosine, right? So we just get something like this. Oops. Bad graph, but it would mean anywhere where the slope is just y equals a constant and no x, just a constant. So that means it's a vertical line, I mean a horizontal line. So we see there's this peak right here, the cosine, there's this one right here. Now we're just going to find out what those points are without trig. I mean, you don't. I mean, realistically, I don't even know. Blah 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 blah. Skibbity. Hold on. Skibbity dub dub. Skibbity dub dee dee. Skibbity dub 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 yes yes. Skibbity dub 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 yes yes. Diddle diddle diddle. Yes yes. Yes, yes. Alright, my bad, guys. Sorry for that pause. The equation wasn't cosine, but I'm just saying, if it was cosine, just cosine, then you would just probably just plug in a number to find this. But since it's square root 3 times x minus 2 times cosine x, it's a little bit more complicated than just finding that. Okay. So let me show you. With this little amount of space I got. Okay, so find the derivative, obviously. So square root 3 times x minus 2 cosine x. So square root 3 is a constant, and this x is not a part of the square root, so it's just 1. So it's just square root 3. Because it's not 0 because it's multiplying the x, and the x turned into 1, so yeah. And now minus 2 times cosine x. Derivative of cosine is negative sin, so it's plus sin 2 sin x. And since it's asking for a horizontal, it must be equal to 0. The slope has to be equal to 0 / a constant. Okay, so 0x is just a constant, by the way. Okay, and then to solve this, just solve it normally. So negative square root x on this side minus and divide by 2 equals sine x. Now you're gonna need your unit circle. You can name unit circle. Okay. Now let's get the 30, 60, 90 triangle. 60, 30, 90. Okay, so this side would be square root 3 over 2. This side would be 1/2, and this would just be x. So they're given here that if it is a sine of something would equal to square root 3 over 2, that would mean it'd be sine of 60 because it's the opposite leg. And since it's negative, that means it's in these two quadrants where the y values are negative. And that would mean that it is lying between 4 pi over 3 and 5 pi over 3. Because those are the only two within 0 and 2 pi that are negative square root 3 over 2 of sine. And that's your answer. It's like, pretend this is like 60 degrees here. But, and then like, you know, yeah. That is what they do. From 0. Okay.